loosely related to the idea of a tuple is the idea of having a couple of specific identifiers, global constants you might be working with in your app, which you want to represent as numbers, but to which you want to assign a human-readable label. And for that, you have the enum type. Again, that does exist in some other programming languages. JavaScript doesn't know it though. It looks like this. This is how you create an enum. You use the enum keyword, which only exists in TypeScript world, not in JavaScript. Thereafter, you have curly braces and then your identifiers. And this type, which is added by TypeScript, gives you an enumerated list. So these labels are in the end just translated to numbers starting at 0, where you have human-readable labels you can work with in your code. To show you an example, let's go back here to our person with its role. I'll copy that code and then comment it out because I'm going to change it a bit. And then here, I'll get rid of that explicit type assignment and instead go back to inference because I'll now change role. And now let's say we want to have an admin, an author, and maybe a read-only user. The admin should have an ID of 0, read-only user has 1, author has 2. Now, of course, we can store that exactly like this with these numbers. One downside is that we can also add a number for which we might not have a role. And if we then later in our code try to extract a role and use an if check, this might lead to errors. And in addition, we as a developer have a hard time to understand which role this user has. Was 2 the author or was it the read-only user? You might forget this after making longer pauses, when working in bigger teams, and so on. So as a developer, we might want human-readable identifiers, something like admin and read-only user, something like that. Now, of course, we could use that. We could work with such string values. The problem is if we then later need that in an if check, we check if person.role is equal to, was it read-only user or was it one word? Was it with underscores? You see, then we have to remember how we wrote these strings, which exact text we have in there. Because this string with the dashes between the words is of course not the same as this string. So here we would never make it in there. Is read-only if we try to compile and print that because, well, the check simply doesn't yield true. We don't have that as a role on person, hence we don't get the output here in the console. So string identifiers also have downsides. Now for such scenarios, it's quite common in JavaScript to define global constants, for example admin, which then hold certain values like numbers or strings. Both is possible. Numbers, of course, can save us some extra code and bits in memory. And there we might have admin, read-only, and author, like this. And down there, we then just have to use that role. Now, the advantage of that is that we can use this everywhere in our code. And therefore here, for example, if I run this code, if I compile it, and then we let this reload, we see is admin here. So this works, and this is a common pattern in JavaScript. Downside is that now again, role is inferred to be just a number. So we could store any number in there, even a number which we don't support. And in addition, we have to define all these constants. We have to manage them. This is where an enum can save us work. This is totally fine, but an enum makes it easier. We create an enum with the enum keyword. We can name it role. Convention is to start with an uppercase character because an enum also is a custom type. It's your first custom type. You're going to write many more in this course. This is the first one. And then after the name of the type you want to assign to this enum, you add curly braces, just like that. No colon, no equal sign, just curly braces after the name. Then a semicolon. And now in here, you can assign your values like admin, read-only, and author. And behind the scenes, this here receives the number 0, this here number 1, this here number 2. And then here you can access role.admin, like on an object, you access your identifier, and you can use that anywhere else in your code as well. Here we can check if the role is author, and then print author. And of course, we shouldn't see that if I run that now because we assigned a role of admin here. But the key takeaway is that we did all of that with the help of the enum, which assigns labels to numbers. If we have a look at that in JavaScript, so in the compiled code, We see this is how it's rebuilt. In the end, it's rebuilt with a iffy here, so a function which executes itself. And role here simply is managed as an object in the end, which has an admin property, a read-only property, an author property, where we then store our number values here, you could say. So it's a bit more complex than that, but that's what TypeScript in the end does here to replicate this enum construct in JavaScript code when it compiles the code. Here as a developer, we simply have these conveniently created numbers. If you hover over them, you see the number which was stored in there, and you can use these numbers here in a human-readable way. Now for enums, you're also not restricted to the default behavior. Let's say for some reason you don't want to start with 0 as a starting number, then you can add an equal sign here after your identifier and enter any other number, and now admin is assigned to the number 5, and the other identifiers after the identifier where you assigned a value pick up on that and simply increment this starting value. So now we have 5, 6, 7 instead of 0, 1, 2. You of course also can assign your own values to all these identifiers if you need your own numbers. You're also not restricted to numbers. You can also go with text here or even mix it like I'm doing it here. Anything goes there, but often the default of incrementing numbers that start at 0 is what you want. But if you need a different behavior, if you wanna use a string in here and then a number here and here a number as well, or maybe another string, then you can absolutely do that. The advantage is you define it up there, and then thereafter you always just refer to your role type, to this custom type you created, to this custom enum you created, and you use that in your if checks and your type assignments, and you're good. That's the power of the enum, and it's a great construct whenever you need identifiers that are human readable and have some mapped value behind the scenes. With that, we're almost done with the core types. There is one more type which we already saw, and that's the any type. The any type is the most flexible type you can assign in TypeScript. This type doesn't tell TypeScript anything. It basically means you can store any kind of value in there. We got no specific type assignment. TypeScript will basically never yell at you when you use any. Back in our code here, if I would set the type of favorite activities to any, would not get an error. If I set it to any array, I at least tell TypeScript that favorite activities is an array of something. So if I would store just a single value in there, I would get an error. But as long as it is an array, I can store whatever I want in there. So any is really flexible, and this can sound great at first, but actually it's a big disadvantage, and you absolutely want to avoid any whenever possible, because any takes away basically all advantages TypeScript gives you. It gives you the same experience you have with vanilla JavaScript, where you also have the any type on everything, so to say. Any basically makes sure that the TypeScript compiler can't check anything. Because if any property or any variable can store any value, well, then there's not much to check, right? So you can use any as a fallback if you have some value, some kind of data where you really can't know which kind of data will be stored in there, and where you then maybe are using some runtime checks, like we did here, at runtime to narrow down what you want to do for certain values, then you could go with any. But in other cases, you really want to avoid any. If you have a chance of knowing which kind of data you're working with, be explicit about it. Let TypeScript's inference do its job, or explicitly set your own types. Don't fall back to any if you don't need to. So we covered a couple of the core types TypeScript knows. Now let's move on. And for that, I'll rename app.ts here to objects, arrays, enums, or whatever you want to name it, basically so that we still have that file, but I'll create a brand new app.ts file so that we have an empty file again in which we can work. Now in this file, I want to dive into another interesting type which you find in TypeScript, and that's the union type. Now what's that? Let's come back to our add function which we wrote earlier. I'll copy that and move that into app.ts, get rid of that comment here. And here on add, let's close basics.ts so that we get rid of that error. Here in add, I now want to be more flexible regarding what we accept here. I will also get rid of show result and phrase. I don't need that. And the only thing I want to do is I want to calculate a result and return it, but I want to be more flexible regarding the inputs. Previously, we made sure that we only work with numbers. Now let's say we actually name this combine, and it should work with both numbers and strings, because it turns out we can combine both numbers and strings with this plus operator. The only difference is that in one scenario we get back a number as a result, in the other scenario we get a concatenated string, as we actually already saw earlier in this module. But now I want to allow this behavior, because you could have an application where you want to have a flexible combination function that does work with numbers and strings. Therefore, I will also name this input 1 here and this input 2, and combine these two now. But we will have one problem, of course. Right now we set both parameters to be numbers. This means that we can call this function as long as we do want to work with numbers. Let's say down there we're creating a new constant, combined ages, and there I call combine and pass in 30 and 26 here as ages in whatever application we're building. And I thereafter console log combined ages. Well, it shouldn't be too surprising that if we now compile this file here and we then reload this page, we get 56. So this works, we get this number. But of course we have a problem if we try to create a string here. Combined names, for example. If I try to combine Max and Anna here, then well, we immediately get an error here that Max is not assignable to type number, because this of course is a string. Now of course we could change this to accept strings instead of numbers, but now the first function call would fail. And that is where union types can help us. If we have some place in our application, be that a parameter of a function or a constant or a variable we're using somewhere, where we accept two different kinds of values, well then a union type can help us. To tell TypeScript that we are fine with either a number or a string, we use number and then the pipe symbol here, and then the other type we also accept. And you can have more than two types, you can accept as many types here as you need. So here I only need two though, and that's therefore the type assignment I'll go with, number or string. Now I get an error here that the plus operator cannot be applied to type string or number and string or number. That's actually not entirely correct. This should work because we can use the plus operator with both numbers and with strings, but TypeScript only sees that we have a union type here and it doesn't analyze what's in the union type. It just sees, okay, you're expecting multiple types. Maybe that includes types where I can't use the plus operator, hence I will complain here. Now, thankfully, we can work around that issue though. We can add our runtime type check here and see if input 1, if the type of that is equal to number, and if the type of input 2 is equal to number, and then move this calculation in there. Now just one improvement. Let's create result as a variable outside of that if check because of block scoping, so that this is a variable available in the entire function, and then just assign a new value in there. So now here we check if we do have two numbers. And therefore TypeScript knows that in here, input 1 and input 2 both will be numbers. Now let's add a else check here. And there we can set result equal to input 1 dot to string, explicitly converting this to a string, and input 2 to string. And this will then also be fine for TypeScript and JavaScript because we can concatenate two strings. So now we have almost the same calculation, but we make clear that here we'll always work with numbers, here we'll always work with strings, and then we return the result. And now with that, if we console log the combined names down there, and we compile this file, we'll see that once we revisit our page, we got the combined numbers there, which were simply added together, and hence we get a number as a result, and the combined names here. So this is how we can use union types to be more flexible regarding what we do in a function, for example, or anywhere else in our code. This extra runtime type check will not always be required when you work with union types, but often it will be, because with union types you can be more flexible in, for example, the parameters you accept, but then you might have different logic in your function based on which exact type you are getting, so that your function is able to work with multiple types of values, but that it then does slightly different things depending on the type you're getting. So often you might need such a runtime check when working with union types, but you'll not always need it. You will certainly also encounter situations in TypeScript programs where you can use a union type without a runtime type check. It really depends on the logic you're writing. So now we got union types here. Let's build up on that idea of union types and also introduce literal types. Literal types are types where you don't just say that a certain variable or a parameter should hold, let's say, a number or a string, but where you are very clear about the exact value it should hold. We saw that early already, here in basics, const number 2, for example. There, if I hover over that, you see the type which was inferred is not number, it's 2.8. And TypeScript did infer this concrete number as a type here because it's a constant. It will never change, and therefore TypeScript knows the value I assign here is the exact type I have. So of course this is a number. You could say 2.8 is derived from the number type, but it's a specific number. And this does not just exist for numbers, but also for strings and so on. And especially for strings it can be very useful. Let's say here in our combine function, we expect numbers or strings and we combine them differently based on what we get, but we also want to allow the caller of the function to define how the result should be returned, so that we can basically force a conversion from number to string or the other way around. We could do this with a third parameter, and we could name that, let's say, result type or result conversion, or however you want to name it. And I want to describe this with a string, so I'll set this to type string. Now my idea is that I can call combine here with two numbers, and for example pass in a string of as number. And it's totally up to you which identifier you use here. Down there we might have as text, but then we might have another combination here, combined string ages, where I pass in two strings, but I still want to output this as number. And this would be a case where the third parameter can be helpful to force a conversion. Because if I pass in two strings here, normally we would make it into this else branch and concatenate it. And I might want to return this as a number instead, so that I can also console log combined string ages here. So now we just have to take these identifiers into account in our function by including result conversion in our if checks. Now the question is, what exactly do we want to do? Do we want to make sure that we can force these two strings to be added as numbers? Or do we want to force the result, no matter if it was a mathematical calculation or a string concatenation, to be converted to a text or a number? If we want to force a conversion, we could add the if check here and check if result conversion is equal to as number. And if that's the case, I want to return result with a plus in front of it, which converts it to a number. The alternative would be parse float, for example. But here I'll just go for the plus, since this is a bit shorter. And else I want to return result to string to force an output as a string. So now we do the calculation based on the real type we get, but then we convert the result. That's one way of doing that. And if we save that and we then compile this file, we see this is the result I get. And we get that output, for example, for our string combination here, because, as I said, the combination itself, the calculation, so to say, is performed based on the type we feed in, which here is a string, so we concatenate it, and then we just convert the result. The alternative logic would be to check the type here and do a different operation, based on the return type we're specifying here. So we could comment this out and instead here say if the type of input 1 is number and the type of input 2 is number, or if result conversion is equal to as number, then I want to combine values like this. And now to avoid this error, here I force the conversion to numbers by adding a plus in front of each input, so that each input is converted to a number and is guaranteed to be a number before I combine them. Side note, if you would pass in strings that can't be converted to a number, so something like max for example, then you'll get NaN, not a number as a result. Well, and in the else case, so that we don't have as number or that we simply don't have number inputs, then we make it into this block here. And now with that, if I return result again here, and we then save this and recompile, we'll see a different output on our page. Now we get 56 in these two lines here, because now we're not converting the result, so we're not converting the concatenated string for this line, but instead we're doing the conversion before we combine the two values. So that's up to you which logic you want to implement. I actually want to have a closer look at the literal types concept, which I described at the beginning of this lecture. I'm passing in as number and as text, and the downside of this is that right now we as a developer have to memorize these values. We have to make sure that we don't mistype here. Now we could use a enum to improve that, but if we only have two values here, as text or as number, then maybe also such a literal type could be an option. We could say this shouldn't be any string, it should be as number or as text. So we use a union type combined with literal types. Literal types are the types which are based on your core types, string, number, and so on, but you then have a specific version of that type. So here we allow specifically these two strings, not any string, just these two strings. So we want a string for result conversion, but it has to be one of these two values. Any other string value will not be allowed. So that's the idea behind a literal type. And often you will use this in the context of a union type because you don't just want to allow one exact value. You could hard code it into your code if that would be the case, but you want to have two or more possible values. In this case, we got two possible values. So now we are guaranteed to get result conversion, which is either as number or as text. And for example here, if I now try to compare this to as num, because I have a typo here, TypeScript is able to tell me here in the IDE, and of course also if we save it and compile it here in the terminal, because it knows that as number without a R at the end will never be a valid value for a result conversion because I set this union type with these literal types. So now we again gain some extra type safety and ensure that we can't use this incorrectly. The same of course for passing in a value. If we have a typo here, we get an error. Only if we use either as number or as text, we're allowed to compile this. As you see, if I now compile this, this works, and we get the same output as before here. So these are literal types, especially useful when used in conjunction with union types. Now, when working with union types, like this and this, it can be cumbersome to always repeat the union type. You might want to create a new type which in the end stores this union type. And you can do that with another cool TypeScript feature, the feature of type aliases. You create such an alias, typically before you use it, so here at the top of the file in this case here, with the type keyword. Now the type keyword is not built into JavaScript, it's supported in TypeScript though. And after type you add the name of your custom type or of your type alias, I should say. For example, combinable, but the name is really up to you. You can invent any name here which is not built into JavaScript or TypeScript as a key name. So something like date would not be allowed because that's built into JavaScript, but combinable is not built into JavaScript, not built into TypeScript, so we can use it. And now with the equal sign, you assign the type you want to encode in your alias, so to say. So we could store a number here, and now whenever we want to make sure that something should be a number, we could use combinable instead. Now, that doesn't make too much sense. It arguably would even make our code harder to read. If I use combinable down there, for example, this would work technically, but if we just glance over our code, it's not obvious that here we want a number or a string. Well, typically, therefore, you use that in conjunction with union types. So we can store a union type in our custom type, so to say, in our type alias, and now just refer to combinable down there instead of our union type. So we have exactly the same setup as before, we just have our reusable type alias here, which we can use instead. And that allows us to save some extra code and make sure we always refer to the same types or the same type setup when we use combinable. And of course, we cannot just use that for number and string, we can use that for any type setup we might want to store in an alias, including these two literal types, for example. So for these two types here, for this union type, we could also create a type alias, conversion descriptor, or however you want to name it, and store exactly this type in this type alias. And now we can use this type alias down there. So type aliases are really useful. You can encode more complex type definitions into your own types, into your own type names, so to say, and reuse that everywhere in your code where you need exactly this type setup, so that you avoid typos down there, and you can simply save code, write code quicker, and also be clearer about your intentions, for example, by choosing descriptive type alias names up there. Time for another new file. I'll rename app.ts here to union aliases.ts and add a new app.ts file where we can start from scratch again, close the other file. And now in here, I want to dive a bit deeper into functions. Now, of course, we already worked with functions, for example, here in the union aliases file with the combine function. And for example, you saw that for functions, you can assign types to the parameters of functions. Well, turns out there's a bit more you can do with functions and types. For that, I'll recreate my add function, which simply accepts numbers, not strings, which does one simple thing. It returns n1 plus n2. So not too tricky. Now, as I mentioned, we can assign types to parameters. That's not new. The function overall, however, has one important other type. It has a return type. And here the return type is inferred by TypeScript. We can see it if we hover over add. Here at the end, the colon after the parameter list, this here describes the return type of the function. So the type of the returned value. Here I return the addition of n1 and n2, and since both these inputs are numbers, TypeScript is able to infer that the result of this will be a number, and since we return it, that the return type of this function therefore will be a number. If we would concatenate them as strings here, with toString for example, then TypeScript would correctly infer that we return a string here. Now, of course, we can also explicitly assign a return type here by adding a colon after the parameter list and then the type you want to return, like number. This would be the same type as inferred. If I, for example, set this to string, I would get an error here because obviously my calculation here does not match my described return type. Now, just as with variables, it's a good idea to let TypeScript do its job regarding type inference. And if you have no specific reason for explicitly setting the type, you should therefore not set the type and instead let TypeScript infer the type. Regarding the return types, though, there is one interesting type which we haven't seen before and which might be brand new to you if you have no experience with other programming languages, because it is a type that doesn't really exist in JavaScript. It's the void type. Let's say we have the print result method. There we get a number argument, which should be a number. And in there, I want to console log num, and I want to console log it as part of a string where I say result plus num. So now this will be concatenated to one long string and will be output. And now I can call print result and, for example, pass to that the result of my add function call with 5 plus, let's say, 12. So I'm executing add here with two numbers, and the result of that, so what add returns, is then passed as an argument into print result, and that should print it to the console. If we now compile this and then have a look at that in our page or on our page here, we see result 17, which makes sense. Now the interesting thing here is the return type of print result. What would you guess is the return type here? So maybe you think it's string because I'm creating a string in here, but keep in mind we're not returning this. We're not returning anything here. And therefore this print result function here has a special return type, void. Now you might know this void return type from other programming languages. There you have something like this. JavaScript doesn't really know that or doesn't really have a name for this situation. TypeScript, however, does. So indeed, this function here has a return type of void. And of course, you don't need to specify it here. TypeScript's inference did its job. But I want to make it really clear that this has the void return type, which is why I am adding it here for demo purposes. Now, void really just means this function doesn't have a return statement. It doesn't return anything. It successfully completes, it does its job, it executes its code, it does not yield an error or anything like that, but it then does not return anything. That's the void return type. Now, technically in JavaScript, of course, if we would console log the result of print result here, and I now compile this and we see what gets output here on the page, we see that undefined is returned by that. So technically, and that's really interesting, in JavaScript, if we use the return value of a function that doesn't return anything, we get undefined as a value. And as you probably know, undefined in JavaScript is actually a real value. A value you, for example, also get if you try to access a property on an object which doesn't exist. So here we get void, even though technically this returns undefined. And now to make it even more confusing, undefined actually is a type in TypeScript. You can have undefined as a type, and for example, a brand new variable, some value, can receive undefined as a type, and you will not get an error. This variable will now just be forever undefined. How useful that might be is a different question, but undefined is a valid type in TypeScript. Nonetheless, here you see we're getting an error. And we're getting an error because a function is not allowed to return undefined. Technically, it of course does, but TypeScript thinks about functions a bit differently. You should use void here if a function returns nothing and not undefined, because with void you make clear that this function deliberately does not have a return statement. If you would say undefined here, then TypeScript would expect that you have a return statement where you just don't return a value. That's the technical difference. Now you see I'm not getting an error. From a JavaScript perspective, this is basically the same as this, but TypeScript makes a differentiation here, and therefore void is the type you want to use if you don't have a return statement. Undefined, which you will rarely need to be honest, can be used if you return without returning an actual value. But again, this is a rare use case, and you could use void with a return statement like this as well. You would not get an error, and by default you would actually also use void in this scenario, unless you really have a function that should produce undefined and you want to be clear about that. But again, that will rarely be the case. I just want to make sure here that you understand the difference between void and undefined, that void is the standard which you'll use in pretty much all scenarios where you have a function that does not return a value, and that you can assign it explicitly, but of course TypeScript also is able to infer it, like it would be able here as well. I just added this for demo purposes here. So you can use types for function parameters and for the return value of the function. Now, to take it to the next level, what if there also were a function type itself? Now let me make it clear what I mean. Let's say we have a variable, combine values, and this variable by default has a type of any. Now as you learned, any is not that useful. What I want to do eventually is, I want to set combine values equal to add. So I want to store the add function, a pointer at this add function, in combine values, so that in the end we can console log combine values and execute combine values as a function to which I pass 8 and 8. Now if I save that, and I execute this after compiling it. So if we compile this file and then we let this reload, we get 16 here. So that works, and we would expect it to work because that is normal JavaScript code. We can store a pointer at a function in another variable and then therefore execute this variable as a function because, well, it points at that function, right? So we can execute that function through that variable. The problem we have with this snippet here from a TypeScript perspective just is that combined values is any. So if I set combined values to a number here thereafter, of course, we can compile this, unfortunately, because TypeScript has no chance of detecting that this is unwanted or that this could cause a problem. But at runtime, we would get an error, because obviously we try to execute combined values as a function when it actually is a number. Now we want to avoid this, and for that we need to be clear that combined values will hold a function. Now a first step into that direction is that we set the type here to function. Function is a type provided by TypeScript in the end, and this makes it clear that whatever we store in here has to be a function. Therefore here I'm getting an error because 5 is a number and not a function. And if I comment this out, we can compile this, otherwise we would get an error during compilation, and now this again runs as expected. So that's good, but it's not perfect, because now we say this should be a function, but it could also set combined values equal to print result, for example, here. And of course, TypeScript would not complain because print result is a function, but of course, it's not a function that takes 2 arguments. So again, if I compile this, TypeScript will not complain, but if we reload, we see undefined here and result 8. So I don't get the result I want because I stored the wrong function in there. Again, it would be nice if TypeScript would tell us about that. TypeScript can't inform us about this because all we said to TypeScript is that we want to store a function in there, and this is clearly the case. So it would be good if we could be more precise regarding how the function should look like that we want to store in combined values. And that's where function types come into play. Function types are types that describe a function regarding the parameters and the return value of that function. A function type is created with this arrow function notation you know from JavaScript, or at least close to that notation. You don't add curly braces here because we aren't creating an arrow function here. We're creating a function type instead. Now on the right side of this arrow, you specify the return type of the function you eventually want to be able to store in here. And that should be number. Now with that we're saying combined values accepts any function that takes no parameters and then returns a number. Now that's of course not entirely what we want. We want to make sure that combined values takes a function or is able to store functions that take 2 numbers and return a number. Now for that we can add parameters here to this function type. We don't have to match the parameters names from up there, just the types. So we could have A, which should be of type number, and B, which should be of type number. And now what we're saying to TypeScript is that combined values should accept any function that takes 2 parameters, where each parameter is a number and where the function overall then returns a number. And that's why TypeScript does not complain about us storing add in combined values, because add is a function that perfectly satisfies this type definition. But it does complain about print result, because print result, as it tells us here, is a function of type 1 argument, which is a number, nothing is returned, whereas we actually expect to get a function with 2 arguments, where each argument is a number, and we also return a number. So we have a mismatch here, and if I would try to compile this, we therefore would get an error here, of course, in the compiler, and we only can fix this by removing this line of code. Now we are able to recompile this without errors, and now this runs as expected. So function types allow us to describe which type of function specifically we want to use somewhere, be that an expected value in a parameter, if we create a function with some callback, or like here, a variable. Now speaking of callbacks and function types, there it works pretty much in the same way. Let's say we have a new function up there, add and handle, let's say. And there we expect to get 2 numbers. And then I also want to get a callback function here, so a function which is passed in as an argument that should do something with the result. Then here we could generate the result, of course. But now I'm not returning it, but instead I want to call the callback function and pass in result. Now for that I want to be really clear that callback should be a function. So again, I'm using that function type definition that maybe does not return anything, but that does take a number as an argument because we're passing in a number here. So the callback function, the function we're passing into this function as a parameter, should accept a number. And now down there we could call add and handle, pass in 10 and 20, and then pass in a function, for example, an anonymous function here. So now here when we call the function, this is of course not a function type, but a concrete value we're passing in for this third argument. So this now here is an anonymous function I'm creating here. And there we know we'll get a number, maybe name it result here, and then we can do with it whatever we want. And now if we compile this, we see this log down there, 30, which is the result of our callback function, which we pass to add and handle, where add and handle combines the 2 numbers and then calls the callback, where the callback has to meet this condition here. The advantage of us defining the callback function definition here is that inside of the function we pass in as a callback, TypeScript is able to infer that result will be a number, and hence we could do anything with result here, what we could do with a number, without explicitly stating the type here. Because TypeScript knows result will be a number, because we made it really clear that the callback will get one argument, which is a number. Hence, also if we would expect a second argument here in the callback, we'd get an error, because we know, well, the callback we expect in our add and handle function only should have one argument. So if we then pass in a callback function which takes a second argument, that clearly is a mistake. The only thing TypeScript does not pick up is if we return something here. If I return result, then the callback does return something, even though we made it clear that it shouldn't return anything. This, however, is not a mistake or a bug in TypeScript. It actually happens on purpose. By specifying void here on our callback type, we're essentially saying we'll ignore any result you might be returning here. So we're basically saying in add and handle, where we get that callback function, will not do anything with the return type. That's why you'll be able to return something here without punishment, but you know, because it's clearly defined here on the callback type, that the callback will not do anything with the value you might return here. So that add and handle inside of the function will not do anything with that value you might be returning. And that's of course a useful piece of information. You might expect that in here we're doing something with the value returned by the callback. And by specifying this type here, we make it really clear that inside of add and handle, we're not interested in any return value. So this does not force you to pass in a callback that does not return anything. It just tells you that anything you might return will not be used. For the parameters, it's of course different. There, this is enforced, because here it really matters that you know if you're passing a callback that expects more parameters, well, then you'll get an error or you'll not get the result you want because I only give you one result. So there we can't just ignore what you might want, as it's the case for the return type. We can ignore that here. For passing something in, the add and handle function is responsible for that because that's where the callback gets called. This is why parameters are enforced, and TypeScript is really strict regarding the number and type of parameters of callback functions, and why it doesn't really care about the return type. We're almost done with the basics about TypeScript and the core types. There are 2 more types which are good to be aware of because they will matter from time to time. The first type is the unknown type. For that, I'll name this file here functions.ts and add a new app.ts file. And in there, let's say we have a new variable, user input, and this is of type unknown. It's not of type any, which would be the default, but unknown, which is a different type introduced by TypeScript. It might be unknown because we don't know yet what the user will eventually enter. If it's a number, if it's a string, we don't know. Now, the interesting thing about the unknown type is we can store any value in there without getting errors. So this is all allowed. If I now compile my file here, you see I get no compilation error. So thus far, it's the same as if we wouldn't have assigned a type here, and hence we have the any type, or if we would have explicitly set any as a type. But still, unknown is different to any. This here works, but we'll run into issues if I have another variable, let's say username, which should be a string, and that's uninitialized here, but then here I want to set username equal to user input. Now you see we're getting an error that type unknown is not assignable to type string. So username wants a string, and of course unknown is not guaranteed to be a string. Here I assigned one, but that's just the case in this line. User input technically could hold any value because it's unknown. Now the interesting thing is if I switch unknown to any, this error goes away because any is the most flexible type in TypeScript, and it basically disables all type checking, and TypeScript just says, I give up, do whatever you want. Unknown is a bit more restrictive than any. With unknown, we have to first of all check the type that's currently stored in user input before we can assign it to, for example, a variable that wants a string. So since a string is wanted here, we could check if type of user input is equal to string, and TypeScript will detect this check and understand that in here, what I store in username, because it's inside of this if statement where I check for a user input being of type string, user input is guaranteed to be a string, and therefore I can safely assign it to username. So I need such an extra type check here with unknown to be able to assign an unknown value to a value with a fixed type. And therefore unknown is the better choice over any. If you know, I can't tell exactly what type I'll store in there. It might be a number, it might be a string, but I know what I want to do with it eventually. Well, just add an extra check to make sure that what you want to do can be done, so that if you want to work with a string, you have a string and you're good. And then unknown is better than any because it makes sure that you're not allowed to do everything, but you have at least some type checking. Of course, if you have a chance of knowing in advance that user input is always a string or a number, well, then you should use string or such a union type instead of unknown. So unknown still is a type you shouldn't use all the time, but it is better than any for the reasons described. The last interesting type I want to show in this module is the never type. Now we saw a function that returned void, so that never returns anything. Never is another type functions can return. And that might sound strange. Let's have a look at how it works. Let's say we have a function generate error. Here I expect to get a message, which is a string, and maybe some error code, which might be a number. Now inside of this function, let's say, we throw an error. So this should essentially be a utility function that generates error objects and throws them. So here we might throw an object, which we can do in JavaScript. We can throw any object or any value as an error. And that should have a message property in which I store the value of my message argument here. And I want to have an error code property, let's say, where I store the code argument in. So now this would be a valid function, and we can call this with an error occurred, for example, and a code of 500. If we do that and we compile this file here, we see that once this reloads, we get our error, well, as an error here. And this might sound pretty abstract, but actually it isn't. Having utility functions like this would be pretty standard in bigger applications where you don't manually want to throw an error in 10 different places of your app, but where you want to reach out to one convenient function that builds the error object for you and maybe also throws it immediately, so that you can call this function with different inputs, but you always have an error being thrown. Now the interesting thing about this function is it does not just return void. I actually can specify that it returns void, because of course it returns nothing, but actually it does not just return nothing. If we're totally honest, this function returns never. This function never produces a return value. If I would try to store the return value here, and I console log result, and I then compile my code and this executes, we see there is no undefined being logged here, because since an error is thrown, this essentially crashes our script, you could say. It cancels our script. And this will always be the case for this function. Of course, we can wrap it in try catch so that we can still continue in the script, but this function essentially never produces a value. This function always crashes the script or this part of the script if you're using try catch, and therefore never returns anything. And hence the return type of this function actually is not just void, but also never. Now the interesting thing is, if you hover over it without assigning never, you see the inferred type is void. Also because never is a newer type. It's been around for some time now, but it wasn't built into the first versions of TypeScript. And therefore void is typically assumed, and it's not horrible to leave it at that. But you can be very clear and explicitly set never as the return type to make it really clear that this never returns anything. So from a code quality perspective, this might be clearer regarding your intentions and make it really clear to other developers reading your code that this function is intended to never return anything and to essentially crash or break your script or that part of the script. Another function that would never return, by the way, would be a function with an infinite loop. So if we have while true in there, that creates an infinite loop, and that therefore also would be a function that never returns. The error function here, or the function that generates and throws an error, probably is the more common use case though. So never, also an interesting type which you can use on functions for cases like this one here. Now with that, we had a thorough look at all the core types and the TypeScript basics. You hopefully now understand how we create and assign types, how we assign types to variables and to parameters and why we do that, how type assignments in TypeScript differ from JavaScript type checks, that JavaScript uses runtime types and TypeScript uses static types that matter during development, that the built JavaScript code therefore does not include any type assignments. It of course includes any type checks because that is regular JavaScript code, but something like this here, this is simply not allowed in JavaScript. This is not supported syntax. That's TypeScript only. So that's hopefully clear. And then we had a look at numbers, strings, booleans, at function types and setting return types, argument types, and also describing the type of an overall function, which can be helpful if you want to have a variable that eventually holds a function. We had a look at objects and arrays and enums and how that can be interesting and help you. The same is true for tuples. And now we also had a look at aliases, type aliases, where you can merge complex types into aliases which you can reuse. We had a look at literal types and union types, which can be useful for scenarios where you expect more than one possible type. And now at the end, we also had a look at unknown and never, which are niche types, but still in their niche, they can be very useful. And now with these basics, we'll dive deeper into individual aspects and of course also explore other types and JavaScript constructs where TypeScript can be helpful.